Polynomials of the form f of x is equal to ax to the n plus bx to the n minus 1 plus cx to the n minus 2, etc., etc., etc. And the last numbers are plus g times x plus h. Then all the rational zeros are of the form factors of h, all divided by factors of a. So, for example, f of x is equal to 2x to the 4th minus 5x cubed minus 3x squared plus x minus 3. That's x to the 4th.
Okay, no, I'm talking over there on that. Like,
X to the nth.
okay.
N minus 1, n minus 2.
I can't
You're at a bad angle there. Alright, so for this one, if we have any rational zeros, they're going to be of the form factors of -3 divided by factors of 2. What are all the factors of -3? -3 and 1, or 1 and -3, correct? All the factors of 2, 2 and 1, or -2 and -1. Easy enough? What really stinks is when you get something like the factors, what are all the factors of 12 and 3? Because then you start getting into a ton of them. 1, 2, 3, 4, 6, and 12. Ooh, let's make it really nasty. 6. 1, 2, 3, and 6. So all the factors, that means the factors could be 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. Or 1 over 2, 2 over 2, 3 over 2, 4 over 2, 6 over 2, 12 over 2. Or 1 over 3. You see how this gets annoying? Okay. Now, if there's repeat factors, do you have to try the factor twice? No. You don't have to try it twice. But you do have to list them all. So I could have 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1. Then we go to 2's, 1/2. 2 over 2 is just 1 though, right? Let's list that one again. 3 over 2. 4 over 2, well that's just 2. 6 over 2, that's 3. 12 over 2 is 6. 1/3. 2/3. 3/3 is 1. 4/3. 6/3 is 2. 12/3 is 4. Then we got 1/6. 2/6 is a third. 3/6 is a half. 4/6, 2/3. 6/6 is 1. 12/6 is 2. So, and then we have to check all the pluses and minuses. Ugh. Okay. But that's how it works. Oh, sorry. Okay. Bottom part there, okay? And you gotta check the pluses and minuses for all this. Okay. So, on this problem up here, we're going to find all the zeros, real and imaginary. Find all the zeros, real and imaginary. So, what we have to do is we have to start going through it. So we're going to be checking here. 3 over 2. Positive 3 over 2, negative 3 over 2. 1 over 2, positive and negative. 3 over 1, positive and negative. And 1 over 1, positive and negative. So we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers that we have to check. Okay? 8 numbers that we have to check. These problems are not hard. They're just long. That's all it is. Math is more for the persistent than it is for the brilliant. Some people are like, I used to be smart at math, now I'm not smart. No. You're still smart at math. You just don't want to work as hard. Okay? You're like, oh, it just takes too long. Well, yes, math does take a long time. Anything worth doing is going to take a long time. All right. So, let's do this. 2, negative 5, negative 3, 1, negative 3. First number you want to check? 3? All right, let's try 3. Let's try 3. Any reason you chose 3? No. No? No. Okay. 2 plus 0 is 2. 2 times 3 is 6. That gives us 1. 3 times 1 is 3. That gives us 0, 0, 1. Are you sure?
Yeah.
It works out perfectly. That's one of the zeros. That's one of the factors. 3 worked. Oh, happy day. So guess what? Now we're down to 2x cubed plus 1x squared plus 0x plus 1. Now we can, looking at this problem, do we have to check 3 halves anymore? Is 3 a factor of these? No, by eliminating the 3, we can do the rational zeros again. So we just have to check the factors of 1, all the factors of 1 over all the factors of 2. So 1 over 1 plus or minus, and 1 over 2 plus or minus. So what do you want to check next? Suggestions? Nothing? Let's start with 1/2. How about that? We could go back up here to the original and do it, but let's just keep it getting smaller. There's a reason why. We'll see in just a moment. So 2, 1, 0, and 1. We'll try 1/2. Actually, we'll break this up here. We'll have one group try 1/2. We'll have one group try negative 1/2. We'll have one group try 1. Now, one group try negative 1. All right, pause and break it up so that different people do different groups. Tried 1/2, and that didn't work. We tried negative 1/2, it gave us a remainder, so that didn't work. We tried 1, it gave us a remainder, that didn't work. We tried negative 1, that one worked. So now we factored this into basically x minus 3 times x plus 1 times 2x squared minus 1x plus 1. Now though, this is a quadratic. We know how to solve quadratics, don't we? So first we'll try to factor, but if it doesn't factor, you can always use the quadratic formula. Quick check. 2 times 1 is 2. What factors of 2, are there any factors of 2 that add up to negative 1? Not a positive 2. It'd be negative 2 times negative 1, which is negative 3. Or 1 and 2, which is positive 3, so that one doesn't work. So we have to do quadratic formula. So let's do the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times 4ac all over 2a. Negative 7 all over 4. Ew, gross. Imaginary numbers. That's fine. So if we're trying to find the zeros of this, there are 2 of the zeros. The other 2 zeros we have to find, of course, would be x minus 3 equals 0. X plus 1 equals 0, which is going to give us, we also have x is equal to 3 and x is equal to negative 1. So the steps to this: do the rational zero test, find out all the possible factors, guess and check till you find one that works. It's annoying. It's really annoying. Be persistent. Keep going. So guess and check till you find one that works. Plug it in. So you factor that one out. Then do the rational zero test for this. Keep trying to find factors until you get one that works. Factor it out. Keep doing that until you get it down to a quadratic. Once you get it down to a quadratic, use the quadratic formula or factor it. Or sometimes you can get down to a cubic and do it by grouping or difference of cubes. Okay? But this is how you find the zeros. You can also give yourself some direction if you graph it first. And that can kind of give you an idea of what zeros you want to use. Even if we did down this though, so let's say we found, hey, 3 is a factor. We have to factor that out. Negative 1 is a factor. Let's factor that out. We still have to do the quadratic formula at the end to find imaginary zeros. Okay? Long process. Is it super hard? Not really. It's just long. That's all it really is. It's just long. It's bringing together a lot of different things we've done. Imaginary numbers. Synthetic division. Our new rational zero theorem, but just kind of pulls it all together. All right. That is how you find the zeros. It is possible that they could all be imaginary and this doesn't work, which is really, really, really annoying. None of your problems tonight are like that though. Okay? None of your problems are like that tonight. Alright. Go.